Welcome to Untivision. This is a quick response to a new video published by Alpha Phoenix. As you know, a few weeks ago, Alpha Phoenix published some new experimental measurement. In response, I have published two explanations to the observed the result. But I'm still waiting for his further publication as he promised. Today, I saw his latest video on slightly different issue. Here is my quick response. Let's have a look. Aha, this is his latest video entitled Are Solid Objects Really Solid? Another title is there a speed of motion? Of course. The speed of motion is well defined in mechanics by Newton. And actually, my first response to this title is a little bit confused. Why did he raise this question? Because a solid is a solid. Okay. Now, eventually, I realized that he was confused by the definition of the rigid body when we studied mechanics of solid, especially when you study the if you want to be mechanical engineering, then you have used a proper model to describe the mechanical system. A rigid body is an ideal model. A rigid body is an ionization of the body that does not deform or change shape. So this is just similar to ideal gas. The rigid body is ideal solid, not real. So in my opinion, a more appropriate title for his video is, Are solid objects really rigid bodies? Another thing I would like to make it clear is that this experiment seems nothing new, because one can measure the sound speed in a solid in many ways. And this paper published a few years ago is exactly the same as the method he used, although his experimental setup would appear a little bit more simplified. So there's nothing new with this experimental measurement. And another piece of information is that this measurement has been done over a century, I think. So this is some of the earliest experimental reference. As you can see that people were starting to measure the sound speed in solid in general, long time ago. So it's nothing new. Why did he choose this topic? And by watching his video in detail, I realized that he's trying to mimic Veritasia's approach to interact with the audience. He got a multiple choice answer for his question. How long before the far end of the road moves? Presumably, he's using ideal thought experiment. Ask people imagine that if the length of the steel bar is very long, it would take the night to travel. It would take 1 second for night to travel from one end to another. But in my opinion, these multiple choices are irrelevant. We know that because the wave travel at a finite speed, so therefore the first choice is irrelevant. And the second one, the B, unless you have no idea about this phenomena or the underlying physics, nobody would choose the speed of light perhaps alpha phonics read too many introduction books about the gravitational wave, in which the speed of gravitational wave is assumed as the same of the speed of light. It's just my opinion. And third choice is logic. If everyone have studied how sound wave propagate in sonnet, you don't have to be a physicist. If you have ever experienced the earthquake, you know that the earthquakes can propagate through a sonnet, rocket in most cases. So the third choice is obviously correct. We don't have to use experiment to confirm this correctness. And for example, talking about the earthquake, here is some of the diagram I Googled this morning. You can see that when earthquake occur and different type of wave can be detected. Oh, I forgot to enlarge my profile. So during earthquake, different wave will be generated at the Earth center. So that includes the farthest wave, it's called the P wave, which is a longitudinal wave in nature, just not a sound we hear in air. But bear in mind that the wave, P wave, both P wave and S wave travel through the Earth, mostly rocket. So you can, from this diagram, you can see that the P arrived first. Yes, I remember when I was a child, I have experienced earthquake. So basically, you feel a vibration, very fast vibration, and after a few seconds, you can feel the whole building is moving. So this phenomena, namely how wave or how sound propagate in sonnet, is well known. And furthermore, if you use some modern technology, then you can actually visualize the wave propagate in sonnet, right? So the issue in this video is about how wave propagate in sonnet, right? There's nothing unknown. Besides, you don't have to invoke quantum mechanics. Look at his description here. I just found it a bit amusing. And from this transcript, you can see he said, the current state of art understanding of physics is to create a quantum mechanical wave function for every subatomic particle in every atom of the entire bar. This is untrue, okay? In relation to a standard model, at the most, you can only explain the proton and the neutron, which is made by 3 quarks. That's all. You cannot expect using quantum mechanics to deal with this particular issue, namely how sound travel in the steel bar he used. So quantum mechanics is irrelevant to this effect. We don't have to invoke quantum mechanics everywhere nowadays. The quantum wave, quantum field, and the quantum computing, and the quantum entanglement. No, quantum mechanics have a well-defined or different realm in which we have to use different mechanics other than Newton's mechanics. However, in this particular effect, Newton's mechanics works quite well. So let's just finish his description here, and then probably add in the complicated things that don't really know how they fit in, like gravity, and solve all of these equations simultaneously. So imagine how many atoms are there in this bar, and so on. I think he got some, I don't know where did he got this idea that we have to invoke, we have applied quantum mechanics to dealing with the wave traveling in the bar. I think he's trying to make this simple experiment more sensational. That's my opinion. And by the way, I would recommend that because he could actually do some more serious experiment, although the method may be invented by others. That, for example, this is my suggested measurement. Apart from generate the impulse, okay, along the longitudinal direction, we can generate impulse which has a slanted angle to the bar. Therefore, we will have both parallel and perpendicular impulse. In this way, I expected, at least in principle, we should be able to measure or detect two different waves, namely the P wave, the longitudinal wave, and the S wave, the transverse wave of sound. So perhaps I hope and Alpha Phoenix could do a similar experiment to show the limit of his experimental setup. In the meantime, I'm still waiting for his unpublished result on his observation of the time taken for electricity to travel from the battery to the bulb. Please, if you like, take a like and subscribe and make any comment for this video so that I can focus on making more interesting video. Thank you for watching and goodbye.